Hello everyone, hope you're doing well. So we are on this in the second lecture for acid bases and salts. So in the previous class we discussed about what is an acid according to Arrhenius theory. Still I haven't defined bases. That's okay. We'll do it. Then we discussed about characteristics of acids and we discussed about classification. I just introduced that what all classifications we are going to study. So we discussed on the basis of source classification. On the basis of source, we have organic acids and inorganic acids. So we didn't discuss the uses part. So and the sources, like we can discuss for a couple of minutes. So if we have organic acids specifically, most of the time they ask in the objective questions and in various aspects like what is the source of this organic acid. So organic acids and their natural source. So the very first example we can take is amino acid. So from where do we so the natural sources are protein, butyric acid, rancid butter. So if you remember chemical reaction and equations, malic acid, apples, oxalic acid, tomatoes, acetic acid we already discussed, vinegar, formic acid, sting of bees and ants. Then we have lactic acid, sour milk, oleic acid, olive oil, uric acid is urine, stearic acids, that's in fats. So tartaric acid is we didn't mention tartaric acid. Okay, tartaric acid, that is present in tamarind. Tamarind, even we can say unripe grapes also. Then oxalic acid, we already mentioned tomatoes, or it can be mangoes also. Then moving ahead to inorganic acids, like before that, like we can actually discuss the uses. I'm not going to write it. So we can say formic acid is there. So formic acid, it's found, but it is used in tanning leather and in medicines for treating gout. Then if we say acetic acid, we already know vinegar, and we can actually use it for certain dyes and for cleaning purposes also. These days vinegar is very famous for cleaning various aspects, like various things, like anything you can clean with vinegar. Then we have lactic acid. So lactic acid, like you can say it's present in curd and it is used for souring off any kind of milk. Then citric acid, we didn't mention citric acid. Okay, so we are going to mention citric acid. So obviously for citrus fruits. So most of the time you can say found or used, that is a use, like it is found in citrus fruits and citric acid is something important. So obviously we consume it. So it's not, you can say, strongly acidic, but slightly. Then we can say benzoic acid, one we didn't mention. Now the source we are not going to talk about, but benzoic acid is very much used as a preservative. So the formula of benzoic acid, we don't have to remember the formula of everything over here. Citric, tartric, like if you want to remember, we can write in the molecular formula way, but the structures are always going to be different. So citric acid is C6H8O7. So in the molecular formula we am writing. Tartric acid is C4H6O6. Benzoic acid is C6H5COOH. So I'm writing in this way again because it's an acid. If you remember from the previous class, I talked about organic acid and this particular group in common, COOH group, and that is called as carboxylic acid. Then we can use some. We can discuss some inorganic acids uses also. Then quickly we can move to the next classification. So inorganic acid, we have phosphoric acid, that is very much used in anti-rust paints and fertilizers. Sulfuric acid is used in your car batteries. We can even manufacture detergents and fertilizers from sulfuric acid. Nitric acid is again used in explosives. Most of the nitrogen compounds are used in explosives, right? Trinitrotoluene, TNT. Then fertilizers also. HCl, which is there in our stomach in the form of gastric juice. Otherwise, we can clean metal surfaces with the HCl. Then we have carbonic acid. Carbonic acid is also present in your, you can say, soft drinks. So, any kind of carbonated water. So, it will have carbonic acid. Now, next, we are going to move classification of acids on the basis of their basicity. Now, what is basicity? That we need to understand. So, why do we call it as basicity? We are talking about acids and why there is a change in name. So, again, it has a logic. So, basicity is defined as the number of hydronium ions or H plus ions that can be produced by complete ionization of one molecule of an acid. So again, this has to be in aqueous solution. We are not talking about non-aqueous solutions. Or without water, we cannot even talk about over here. Now, uh, now basicity, we understood it's a number, right? So why do we call it as basicity? See, when we talk about any acid, let's say HCl, and if we talk about base, now bases are those which are having hydroxide ions. Now OH is very, you can say, unique. If it's bonded to the metal, we call it as a hydroxide, and the nature of these compounds are basic. We know about pH, right? So it's on the basic side. Now the OH group, if it is bonded to a hydrocarbon, to an organic compound, then it shows slightly acidic nature and the chemistry is totally changed. That's the beauty of chemistry. Now one particular thing attached to certain thing, like it shows some different chemical behavior. You change it, put it somewhere else, it will show totally different behavior. Now, the acid and base, their main goal, specifically neutralization reaction, is to get neutralized. So they are going to form salt and water. So if this acid and base needs to get neutralized, so this acid require how many hydroxide ions in order to neutralize itself or in order to change itself into water. So one H plus or one hydronium ion require one hydroxide ion in order to form water. So indirectly, this how many number of hydronium ions an acid is going to supply is going to indicate with how many bases, like how many OH negative ions it's going to react to form water. So again, like I'll define formally bases definition later on. Again, according to RNA's theory, that bases are those substances which can release OH negative ions in the presence of water. Like we can just write it over here. NaOH, if you have sodium hydroxide in the presence of water, will give you Na plus and hydroxide ion. So OH minus ion getting released is an identity that this is a base. H plus or hydronium ions getting released is an identity that a particular thing is an acid. So this is a, you can say, goal. Basicity is indicating that basicity of an acid. No doubt it's a number of replaceable H positive ions, but why the term basicity? Because its end goal is what? Its end goal is to get neutralized to form water. So with how many OH negative ions, with how many bases it's going to react in order to form water. So if we have one hydronium ion, it's going to react with one hydroxide ion to form water. So it's getting neutralized. That's a, you can say, goal of acid and base, right? That's a whole chapter we are studying about. So that's why the term basicity. Now, if you go to bases, now they have acidity, acidity of a base. So it's always opposite. Acidity of a base, basicity of an acid. I know it's slightly confusing, but if you think through it, if you clear this in your head, it's not that tough. Okay. So now moving ahead, so based on this, we have, basicity of acids. We have monobasic, dibasic, tribasic. So monobasic is from the term mono. Mono in chemistry stands for one. So when one molecule of an acid on complete ionization is going to produce one hydronium ion, in aqueous solution again, it's called as monobasic. So we have all the hydro acid, HCl, HBr. Remember, we are not discussing strong and weak acids in this classification. It's irrespective of that. We are just defining, you can say, or classifying acids which can release one hydronium ion, two, and three. We even have tetrabasic, but right now I don't want to take that. So HCl, HBr, then we have HF, hydrofluoric acid, hydrobromic acid, hydrochloric acid, all the hydro acids you can actually write over here. So HI, hydroiodic acid, then HNO3 is also monoatomic, nitric acid. We have our organic acid, CH3COH. Acetic acid is also a monobasic because it's basically this particular group. So if you see over here, CH3COH, this I think I took with formic acid in the last video. So CH3CO minus and H positive ion. So remember, this again, we can discuss over here like why only this hydrogen is getting released, why not these hydrogens are getting touched. Because if you see the electronegativity value of carbon and hydrogen, it's you can say somewhere 2.1 approximately, as my memory serves. So if they have the same value for you can say electronegativity, the difference is zero. That means they won't break the bond. Most of the time polar bonds are more reactive. So in this, the polar bond is this one. So if you open this particular structure, so this I told you before also in the previous class, this is polar bond, and polar bonds are always more reactive. So this carries partial negative charge, this is partial positive charge, right? So when this is going to break, right, first thing it will break. Carbon and hydrogen bonds are never going to break because they are non-polar. They are not having difference in the electronegativity value. But OH bond is very much polar because oxygen electronegativity is quite higher compared to hydrogen. So polar bonds are always reactive. So that's why this particular group can easily donate one H positive ion. That's why this acetic acid, in spite of having four hydrogen, it is monobasic in nature. You can even write formic acid over here, this example we took in the previous class. Then we go to dibasic. So dibasic, we have H2SO4 sulfuric acid, H2SO3 sulfurous acid, then H2CO3 carbonic acid. We have oxalic acid, COH whole twice. Then we can even write H3PO3. Now this is you can say slightly exceptional one, which I'm not going to discuss in this video, but definitely we'll discuss. So H3PO3 has three hydrogen, but still we have to check its structure and why it is dibasic and not tribasic. That we can discuss in the next lecture. Then tribasic, we have H3PO4. This is tribasic. And yes, in monobasic you can add this also, H3PO2. This is very much monobasic. In spite of having three hydrogen, it is, you can say, it has the capability to release only one. Again, the, you can say, the concept over here is the polar and non-polar bond, but we have to see its structure in order to figure that out, and that I'll discuss in the next video. Then tetrabasic I'm not discussing right now. Then we go to the next classification. On the basis of strength. Now, usually we are defining the strength based on degree of ionization of an acid. Now, this degree is basically a number for us. The calculative part we are not discussing because that we'll be discussing in your equilibrium chapter later on, not right now. But we are just, we are going to introduce slightly about it. So we know that acids can ionize in aqueous solution to produce hydronium ions. We know that. Now the strength of acid depends upon the degree of ionization. Like how much an acid has the capability to ionize itself into the respective hydronium ions. That is a degree, and that same degree is there for your bases also. So we give with this formula degree of ionization. It's given by the symbol alpha. So the formula will be very much useful when we are going to discuss equilibrium, the numericals over there. So number of acid molecules undergoing ionization divided by total number of acid molecules into 100, because it's always in percentage. So more the ionization of, you can say, ionization of an acid, so more alpha, we say stronger acid. So if alpha is greater than 30%, so we always say that it's going to be stronger acid. So if it is less than, then we consider it as weak acid. See, it's in a simple term right now, but it's not that simple when you're going to study equilibrium chapter. So this is a very generic statement, right? Then on the degree of ionization on the basis of this formula, so now we are going to classify strong acids and weak acids. So we need to remember the examples of strong acids. Strong acids, according to definition, will be what? Any kind of acid which undergo complete ionization in the presence of water. So we can just write. So these are acids which undergo complete ionization in aqueous solution, thus producing higher number of hydronium ions. So these are strong acids. So the examples of strong acids: HCl, Hi is a strong acid, HNO3 is a strong acid, nitric acid, we have H2SO4 which is stronger acid. We can even write perchloric acid, HClO4 which is stronger acid. So we say that all these acids can ionize almost completely, but we never say 100%, almost. Then if we need to define weak acid, you can use the same term, just that you will just write they will undergo partial ionization. I'm not writing the whole definition. So they will undergo partial ionization and will give low concentration of hydronium ions. Now again, this is in comparison to strong acids. So you can define like this: acids which undergo partial ionization in aqueous solution and will give low concentration of hydronium ions, or producing low concentration of hydronium ions. We have HCN, hydrocyanic acid. All organic acids you can add over here. Acetic acid. We have H2S is also weak acid. Carbonic acid is also weak acid. Formic acid you can write. Oxalic acid, COH whole twice. H2SO3 is also weak. Like there can be many. H3PO4 is also weak, right? So there can be many. So remember one thing: if I'm taking HCN in the presence of water, so it's going to give hydronium ion and Cn minus. So even the molecules of HCN will also be there in the test tube, hydronium ions, and you have to use a reversible arrow, and even cyanide ions. So basically, they are having some undissociated molecules. So weak acids will have undissociated molecules. Right? Now the last one, on the basis of concentration of acid, that I'm not going to write. Why? Because concentrated acid means, or we can write one line. So classification of acids on the basis of concentration. So we have concentrated acid, dilute acid. So concentrated, we can always say more acid plus less water. Dilute will have less acid and more water. So you can write it in the statement if it's required, otherwise that will be easy for memorization. Right? So that is all for today's lecture. So I'll meet you again in the next lecture. So please revise all this, and if you have questions, you can email me also, and I hope I'll be able to revert back. But yes, please, like I won't be able to do that too much because a lot of work is there. Anyways, so thank you for listening to this video. If I was helpful, then please like, subscribe, and share, and share with your friends if it was very much informative. Thank you.